Hello, Advanced Algebra. We're on 6.6, functions and their inverses. We will start by talking about the horizontal line test. So before, when we talked about determining if a relation is a function, we talked about the vertical line test. And now, in order to determine if we have a function and if its inverse is a function, we're going to use the horizontal line test. I'll kind of show you what that means. So our objectives today is to determine whether the inverse of a function is a function and write rules for the inverses of functions. Okay? And a vocab is one-to-one function, which we will get to in a bit. So recall that the vertical line test can help you to determine whether a relation is a function. Okay, so, and I'm just going to kind of get your memories a little bit with that. If we have a function, whatever, and we did a vertical line test on it, okay, and I will grab myself a vertical line that I made up earlier. If that graph only touches that vertical line at one point, then you can be certain that that function is a function, that relation is a function. Okay? Likewise, if you're going to use your horizontal line test, if it touches in more than one place, then we know its inverse is not a function. Okay? So in this case, the inverse of this quadratic parabola is not a function. And I know that. So let's take a look at a couple examples here. Let's determine if the inverse of this blue relation, if this has an inverse that's a function. So let's take our horizontal line and let's check out the blue. Does it touch the horizontal line at any more than one place? No, it doesn't. So yes, the blue squiggly line is a function. So blue, well, okay, I said that wrong. The blue squiggly line's inverse is a function. Okay, now let's do the yellow, I'm not so good at this. Okay, let's do the red. Does that ever touch the yellow line in more than one? Oh, yep, it's touching. So no, that has an inverse. That's not a function. Okay, so no. Let's do another one. This one right here. Does that touch the yellow horizontal line at more than one place ever? No, it doesn't. So that means that this has an inverse that is a function. Let's talk about writing rules for functions. So I know we did this before, and hopefully you can kind of remember it. It says recall that to write the rule for the inverse of a function, you can exchange x and y and solve the equation for y. Because the value of x and y are switched, the domain of the function will be the range of its inverse. And the range of the function will be the domain of the inverse. So that is a nice trick that helps you figure out domain and range. I do think that the most difficult part for you guys as a whole will be the domain and range. So knowing that if you found the domain of the function, but you don't know the range of the inverse, knowing that those are the same thing, that's going to help a lot, I think. So let's start this so you can remember how to do it. So you start with f of x equals the cubed root of x plus 1. And remember, f of x is just y, so I'm going to rewrite it with y. And then the what our first step then would be is to switch our x and our y values. So this is now x, and this is now y. And then what we want to do is we want to start solving. Okay? So we're going to solve for this y here. So this is the cubed root of this y plus 1. So I'm going to raise it to the power of 3 to get rid of that cubed root. That'll cancel out that cubed root. If I do a cubed root, or if I do a power of 3 on one side, I have to do a power of 3 on the other side. So what I have now is going to be x cubed equals y plus 1. Okay? And then the only other thing I have to do is subtract 1. And instead of y, I'm going to use my inverse function notation, okay? Because I know this is a function, okay? The cool thing about anything with cubed roots or cubic functions is that their domain and range is all real numbers all the time, no matter what. So if I look at the original function, the domain is all real numbers, the range is all real numbers. And then when I look at the inverse function, the domain is all real numbers and the range is all real numbers. No tricks to that at all. Let's look at this other one here. So it says find the inverse of this. So I'm going to rewrite it with a y. Y equals 1/2 x plus 2, that quantity squared. And we're going to, I think what I'm going to do first is I'm going to write the domain and range, which I probably should have done the other one anyways. So the domain and range of this one, well, it's a quadratic. If you know, you can put anything you want into a quadratic formula. But the range is different, right? Because this is a parabola, and it's moved to the left 2, and it's got a horizontal expansion. So it's, you know, who knows, whatever, gonna look like that. So the range is gonna be from 0 and above. So the range is y is greater than or equal to 0. So that's the domain and range of the original one. All right, well, let's go ahead and find the inverse, and then we'll decide if that inverse is a function. Let's see, we will switch the x and the y around. So we have x equals 1/2 y plus 2 squared. I need to take the square root of both sides. I need to subtract 2 from both sides. So I have -2 plus or minus the square root of x equals 1/2 y. And then I need to multiply both sides by 2 or divide by 1/2. So I'm just going to switch colors again, which gives me -4 plus or minus 2 square roots of x equals y. And I have to leave it as y because you have a plus or minus square root of x. That means you can get 2 different answers out. This is not going to be a function. Okay, so I'm going to leave it as y. I'm not going to put it in function notation. Now, if you accidentally put it in function notation, it's technically wrong. Am I going to freak out? Probably not. Okay, but let's find the domain and range of this inverse. Okay, well, if I get stuck on what can I put in here, I can look and say, well, what was my range? The range is going to be the same thing as the domain of the inverse. So it's going to be x is greater than or equal to 0. And that makes sense because I can't put a negative number in under a square root side. Okay, so that makes sense. But my range is going to be all real numbers. Okay, so I'm just going to switch those inverses, or switch the domain and range of the original and the inverse around. I hope you knew that the inverse of a quadratic is not a function, because the inverse of a quadratic is going to look, like that-ish. Okay? And if you did the horizontal line test, or if you did the vertical line test on this one, on the new one, you would see it's not a function. And if you did the horizontal line test on this, you'd know its inverse is not a function. Same thing. One more page of this stuff. We're going to talk about one-to-one functions. So when both a relation and its inverse are functions, the relation is called a one-to-one function. In a one-to-one function, each y value is paired with exactly one x value. So it's 1-to-1. You can use composition of functions to verify that two functions are inverses, because inverse functions undo each other. When you compose two inverses, the result is the input value x. That means that if you have two different functions, here's their little example. They have f of x and g of x. If they compose it, f of g of x, they put one inside the other, and they reduce it, they get x. And if they do it again, but with g of f of x, so if they compose each other and they reduce it, they get x. If they're both x, then yes, they are inverse functions. So we're going to test that out on a few of these. So I have two functions here, and I'm going to use f of g of x, and then I'm going to do g of f of x. And what I want is for them to both reduce down to just x. Anything else, and they're not inverses. So I'm going to take my g function, and I'm going to put it inside my f function. So instead of writing x here, I'm going to put in this stuff. Okay, so this is 1 over x minus 1, but I'm putting in the g function for my x. And then I'm going to simplify it. Well, 1 over x plus 1 minus 1. I don't really need that parentheses, so I'm going to leave it as 1 over x. And then I have 1 divided by 1 over x. That's the same thing as saying 1 times x over 1, which means it simplifies to x. Yay, that one worked. Actually, I'm going to use a smiley face. I like smiley faces. Let's try this one. Now remember, they both have to work. They both have to reduce to x for these to be inverses of each other. So let's put f of x inside of x for the function g of x. So I have 1 over, and instead of x, I'm going to write my f function. 1 over x minus 1. I almost got confused there. Who am I kidding? I'm always confused. Okay, so let's do this. Let's simplify this part first. I need to switch colors. So 1 divided by 1 over x minus 1. That's the same thing as saying 1 times the reciprocal of this. Okay, so that's just this part right in here. So this is just going to be x minus 1. And then I have a plus 1, which means it simplifies to x, which means I get another smiley face and I say, yes, they are inverses. All right, let's try another one. We will do f of g of x and g of f of x. Okay, so I'm going to put my g function inside of my f function. So this goes in for my x. So 3, there's my x minus 1. So I have 1/3 x plus 1. So let me start simplifying. I need to distribute that 3. So this becomes 1x plus 3 minus 1. which is x plus 2. That didn't give us just an x. So the answer is no, not inverses. No, not inverses, whatever. You don't have to do the other one because as soon as you get one that doesn't work, yeah, it's nothing. They are not inverses of each other. All right, one last problem here. We will check this one. So we have f of g of x, and then we'll do g of f of x. I'm seriously tired of all these colors. I need to get a whole new range of colors. Okay, let's try this. So I'm going to take the g function and put it inside of the f function for my x. So here's my f function. And here's my g I'm putting in. And I'm going to simplify it. Now remember, I have to do the exponents first. So I'm going to kind of distribute that to the 2 and to the x squared, or square root of x. So I still have my 1/4 out here. 2 squared is 4. Square root of x squared is x. And then I'll simplify it one more step. 1/4 times 4x is just x. So smiley face for me. Let's do this one. I'm going to take my f function and put it in for my g. So I have 2 square root of, and instead of writing x, I'm writing 1/4 x squared. Now, let's break this apart so it's a little bit easier to see. So I have 2 times the square root of 1/4 times the square root of x squared. All right, 2 times, well, the square root of 1/4 is 1/2, because 1/2 times 1/2 is 1/4. And the square root of x squared is x. So when I multiply these all together, I simplify to an x, and I can say yes. Woo! I'm happy. So that's the lesson. I know it was kind of long and involved. Like I said, I think you might have the most trouble just with domain and range. Let me know. I am almost always available. So let me know if you have questions, and have a great week.